Morning, guys. Just want to do a quick trig review for you guys before we get into looking at trusses and doing some of that stuff. So, just real quickly, want to run through a few things with you. First one being just a reminder of the trig functions themselves. And so we know the statement, the saying SOHCAHTOA, that we have sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. So just want to do a quick review of what that actually means. So we're going to get on here real quick and do a quick little drawing and kind of go through that. Again, what we're really trying to get to eventually is looking at doing forces and doing our force components. So that's really why we did this. We talked about this earlier in the year, so this should just be review, and hopefully it will be stuff that you remember, and it'll be really easy. All right, so just looking at our right triangle, again, we are going to label an angle. In this case, we're using alpha, which is look kind of like a little fish there, as our symbol for that angle. And it has to be a right triangle, which we know. And so just labeling our sides, everything is in relation to the angle we're talking about. So the one side that won't change is always the hypotenuse, because it's always your longest side. And pardon my handwriting, but I'm drawing on my laptop screen and it doesn't like it very well. But the hypotenuse is always your longest side. And so our hypotenuse is going to be always that side opposite your right angle. And so again, opposite means it's directly across. So if you were to draw a line from here to here, that is the side opposite. So the opposite of our right angle is the hypotenuse. And then from our angle alpha that we've labeled here, the side opposite from that, so we come here, this is our side opposite of our angle. Say opposite of alpha. And then the side that we have left, the one that's next to, and that's what adjacent means, is next to. So our adjacent side, and again, my pen does not like to draw on the screen very well, but that is the adjacent side of our angle alpha. So when we start looking at our trig functions, we shorten it and say sine is opposite of hypotenuse, but we don't really say what it is the opposite of, but it's always opposite of the angle. So when we're looking at this, we want to say that sine is the side opposite from alpha divided by the hypotenuse. And then we're really just looking at the lengths of these things. And so when we get back to it, it's a proportional thing. It's a proportion, and it's saying that sine is the ratio of the opposite side to the hypotenuse, and it will never change for that angle. So no matter how big we make this triangle or how small we make it, that ratio between the opposite side length and the hypotenuse will always be the same for that angle. So whatever that angle is, if it's a 30-degree angle or a 60-degree angle or whatever it is, that ratio will always stay the same. And that's what sine represents. And cosine is the adjacent side length, so the length of the side adjacent to my angle, and that side will always be the same as well. And then we get to the tangent. Tangent is the length of the opposite side over the length of the adjacent side. And we see all of these used in different places. So if we think back to where we were using these, we were using them to find lengths of sides of the triangle given the hypotenuse. And so when we talked about it as a vector, we said, okay, well, we've got this vector, and that vector is our force. And so if we were drawing in that vector, so let's draw that in here real quick. So if I gave you a vector and I said it was going off at this angle, and we knew that the force of that was, let's say, 100 pounds. And so that was our force. And we know which angle it was acting at. So we'll draw in our reference here. Now this is just a reference side. We'll use this here in a second for our x component, but really that's a reference for us. So we have basically this setup. We've got this triangle, but the force we're looking at is this right here. And so we want to know what angle is it acting at. And so let's just say this is maybe 25 degrees. I really don't know if that's the right angle or not, but we'll say it's 25. Then if that's a 25-degree angle, then we know enough to find the forces on these two sides. So we can go in here and say, okay, well, down here, this is my F sub x. And then over here, I have F sub y. And F sub y is just the y component. So it's the amount of this force that is going in the y direction. So we have some of our force is going to want to push my object or whatever it is that this is pressing against is going to want to push it in this upward direction. Some of it's wanting to push it to the rightward direction. And what we want to know is how much of that force is going in each way. One thing we do have to be aware of is they're not going to add up to 100, which we know because it's Pythagorean theorem. It's going to be this side squared plus this side squared equals this side squared equals hypotenuse squared. So they're not going to add up to 100, but we can still kind of figure out what those values are. And so if you remember what we did with this back earlier in the year is we looked at, to find f of x, we needed to identify what trig function best fits the ratio of the sides that we're looking at. So we're really interested in finding f of x. Well, that's the side adjacent to this 25-degree angle. It's next to it. And then the only other thing we know for a fact right now is the hypotenuse. And so if we know the adjacent and we know the hypotenuse, the trig function that best fits that is cosine. Because we say, okay, well, cosine of my angle, so cosine of 25 degrees is going to equal the adjacent side divided by the hypotenuse. So that's kind of what we know. We know that the cosine of my angle is the adjacent divided by my hypotenuse. And that ratio is going to be the same. So even if I changed this and it wasn't 100 pounds, or it was 10 pounds, or it was 30 pounds, or it was, whatever force that we wanted to put in there, this ratio, this statement would still be the same. This value of f of x would change appropriately, but they would be equal always. This ratio would always be the same. In fact, if you want to think of it this way, really cosine of 25 is almost like a proportionality constant. And I know, we're getting into algebra there, but we could almost go to this statement right down here and say f of x, our force in the x direction, is equal to, right button here, is equal to 100, well, actually, we'll do 100 times cosine 25. Because what we're really saying is that cosine 25 is a proportionality constant between these two things, that this ratio between them will always equal whatever that cosine of that angle is for this triangle. No matter how long the sides get, if that angle is 25, that ratio will stay the same. And then if we wanted to find that value, we'd plug it into your calculator, and you'd find, what is 100 times cosine of 25. I'm going to pull up my calculator real quick, and we'll do that calculation. And so cosine of 25 times 100. Well, cosine of 25 is going to be 0.906. And so 100 times that, we're going to end up with f of x equal to 90.63. That would be pounds. So that's how much of my force is pushing to the left, or sorry, to the right. So out of 100 pounds, the object we're pushing on is going to feel 90.63 pounds of force pushing it to the right. And then you can do the same thing for f of y. F of y is the side opposite. So for that one, we're looking at the opposite side and the hypotenuse. Now technically, since we do know what f of x is now, we could use tangent as well. But it's always easier to use the one that was given, because generally that number is going to be a little bit nicer for us. So we're probably going to use sine. We'll say, okay, well, sine of my angle is going to be so sine of 25 is going to equal f of y divided by 100. And so that's kind of the same setup we had over here. And then if we want to solve that, we could then go ahead and do the same thing. We would come in here, we'd say, okay, well then f of y would equal 100 times that sine of 25. And that's going to be the same setup that we saw over here for our cosine value. I'll move it down right here. Okay. And then we could plug that in to our calculator. We can find out what that value actually is. And so for that one, we get 100 times sine of 25. And again, we're just putting this in the calculator. You do want to make sure that you're in the correct mode, which is degree mode. So we get 42.26. So that's how much force we're feeling in the vertical direction. So when we start doing our truss problems, we start looking at how to calculate the force acting on a bridge truss. This is one of the things we're going to be doing. We're going to be going and taking a force acting on a part of the bridge and looking at breaking up its components into its x and y parts. And so we just need to make sure we remember how to do sine, cosine, and tangent, and how that works. And so we'll be doing a lot of the same calculation. They're not initially hard calculations. We're just doing a little bit of algebra, and we're going to multiply both sides by the hypotenuse. In this case, it was 100, but it could be any value depending on what your force is. But we're basically just going to take f of y is going to be 100 times sine of that angle, because again, sine of 25 is the proportionality, the constant, the ratio between those two forces, between this side and this side. So if we're looking at the ratio between these two things, it's going to be equal to that sine of 25. All right, we're going to stop there. I'm going to give you some problems to work on Canvas, and then we'll go on from there to start looking at how to do some of the truss problems. Thanks.